Good afternoon, everyone. My name is Shravan Kumar from Delsoft Technologies, New Delhi. Today is our second day of the 3 days faculty development program on networking simulation using NetSim software. So these are our webinar contents today. So we will have an introduction of the software for those who have not attended yesterday. So we'll have a brief introduction of the software. Then we'll have some introduction of the common problem occur in the MANET, that is sinkhole attack, and its intrusion detection system. Then we will analyze one MANET scenario by increasing the node mobility, how the interference occurs and the result varies. We will see. Okay. So first of all, why use a network simulator for research? So as you know, with the advancement of technology, newer protocols are being drafted very frequently, and it is very difficult to keep updated with the latest happenings. Moreover, analyzing network behavior using traditional analytic methods has become very tough. So it is not easy to manually analyze the network behavior, considering that large number of parameters are involved. Hence, we require these kind of network simulator which provide us an accurate understanding of our network behavior and its associated problems and their solutions. So this is some observation in computer networking domain that network traffic will quadruple by 2017 year. Our network traffic will become 4 times in 2017, which is driven by wireless and mobile communication. As you know, we are growing by these devices. We keep using wireless and mobile devices. 2+ billion videos watched online every day. Mobile tablets, all the sensor devices are adding day by day to form Internet of Things or network of things. So these observations conclude to some key research areas of research and development, that is mobile ad hoc network, MANET, wireless sensor network, cognitive radio network, LTE network, and IoT, Internet of Things. And there is one more thing, that 50% of all research papers in IEEE and ACM refer a network simulator. So you require a network simulator to do your research. Now, introduction to NetSim. NetSim is a scientific tool for designing and validating networks and its protocol, and hence it has a lot of relevance in protocol research and development. In defense, it is used for simulating network warfare. It has a wide range of technologies which is possible to simulate in NetSim. These are internetworks, that is LAN, WAN and wireless LAN, then mobile ad hoc network, WiMAX, cellular network which consists GSM and CDMA, cognitive radio network, LTE, wireless sensor network which includes ZigBee, and now IoT, Internet of Things. So this software comes in 2 versions. One is academic version and one is standard version. So in academic version, you have the provision to design and analyze your network through GUI and by configuring its network and changing the parameters. But in standard versions, apart from GUI, users are provided with C source code of the network protocols, which are implemented based on IEEE and IETF standards. So the purpose of giving the source code is to enable users to edit the standard protocol code according to their own implementation and they can link it with NetSim and analyze the performance of their newly designed protocol. Now NetSim has a huge number of customers varying from industries where it is used for network design and validation, and to defense labs where it is used for network centric warfare simulations, and it is used in R&D labs for protocol development and new technology testing. Then in academics, it is used in network lab curriculum and advanced network lab of graduate or postgraduate courses, and PhD thesis work in PhDs in their research. Now these are some technology libraries that are given in NetSim. So NetSim is divided into some modules or components. So standard users have option to select among these components. So this is a list of the content of each component and their corresponding IEEE standards. For illustration, component 1 consists of protocols implemented in LAN, WAN, wireless LAN like Ethernet, IEEE 802.11, ABGN, AC, and more. Component 1 is the base component, that is all other components require component 1 to run, and it has some common module application in every network where you can generate these kind of traffic like voice, video, FTP, database, HTTP, email, and different kind of other networks, other traffic generation. So in component 2, it consists of network based legacy technologies, legacy network, that is LOHUB, CSMACD, token ring. Then in component 3, it is BGP network, border gateway protocol. In component 4, it is advanced wireless network, that is MANET and WiMAX. MANET is having these 4 protocols: DSR, AODV, OLSR, and ZRP. Then component 5 is cellular network, that is GSM and CDMA. Component 6 is wireless sensor network, IoT, Internet of Things, and personal area network. And component 7 is having via cognitive radio network, that is wired radio area network. Then component 8 is long-term evolution, LTE. Component 9 is military radio network. So these are some components that are available in NetSim. So this is some new technologies added in version 9, the latest version of NetSim. That is IoT, Internet of Things, 802.11 AC, that is gigabit Wi-Fi, rate adaptation algorithm for wireless LAN, and military radios, HF, UHF, and VHF bands has been added. Then network emulator add-on module. This is an add-on module, can be purchased separately, that is used for running the live application in real devices by connected to NetSim. Then interfacing with software. So it has interface with 2 software, that is MATLAB and Wireshark. So many of you have worked on MATLAB. So MATLAB is having some functions that is required in networking. So we can call those functions by writing some codes in Visual Studio environment, and then we can link it with NetSim by building it and creating its DLL. In Wireshark, Wireshark is a real-time packet capturing tool that can be enabled while running the simulation. So when you run the simulation, it will start automatically and capture the real-time packets. And these are some modification made just to improve the functioning of the software. That multi-threaded kernel has been added that increase the speed, and simulation scale up has been done. Now before going to the simulation, I'll give you some brief idea of the common problem, that is sinkhole attack in MANET. So what happened in sinkhole attack is, uh, when you create one scenario of MANET, the sinkhole attack, first of all, sinkhole attack, it is one of the severe attacks in wireless MANET. So in sinkhole attack, a malicious node is there. We call it malicious node because it advertise wrong routing in your network, and it gets all the data sent by the source, and after receiving the whole network traffic, it can either modify it or it can drop them just to make the network complicated. So sinkhole attacks affect the performance of MANET, such as in DSR protocol. So in DSR, you must be knowing about RRQ and RRP, route request and route reply. So the route request is sent from the sources during the route discovery, and on the destination end it sends the route reply, RRP, so that containing the route to reach the destination. But intermediate nodes can also send RRP, route reply packet, to the sources. So that is a loophole in this network. So using this loophole, that malicious node adds a fake route entry, and it gets all the data of the sent by the sources. So it said the malicious node sends a fake route reply with a fake route, and the source node, on receiving this packet, observe that this is a better route to send the packet. So all the network traffic goes towards the sinkhole malicious node, and so that that malicious node either modify it or simply drop it. So this is malicious.c file, and these are some functions which are used in the programming uh, just to have the malicious sinkhole attack. So it is, first function is fn underscore netsim DSR malicious node. So this function is used to identify whether a current device is malicious or not in order to establish the malicious behavior. Then this is malicious route add to cache. So this function is used to add a fake route entry into the route and to the malicious device, and then malicious process source route option. This function is used to drop the received packets if the device is malicious, instead of forwarding the packet to the next hop. So this is the scenario. You can see this one is your source, this is destination, and these are intermediate nodes, and this is your malicious node, device 2. So it sends in between the route reply and gets all the details of sources, and does not send the packet to the destination. Now for the solution of this sinkhole attack, there is an intrusion detection system. So in IDS or intrusion detection system, it monitors the network for malicious activities, and once an attack is identified or any abnormal behavior is sensed, it measures are taken to recover from the attack. Okay, so this system also keep track of the intruders so as to avoid further attacks in future. So in IDS in NetSim, there has two major functionalities. One is watchdog and one is path rater. So watchdog is watchdog timer that is added in the each node. Then the timer starts the moment a packet is sent. So when your source sends the packet, the timer starts the watchdog, and once the packet is forwarded to the next hop within the watchdog time, if the next hop is malicious, then it need not forward the packet. Okay, so a counter is used to keep track of the number of time watchdog timer expires, and once the counter reaches the failure threshold, the current node marks as malicious and send it for blacklisting. Then the path rater, this adds malicious node to blacklist and validates routes by verifying route reply and discard route reply if blacklisted nodes are present in it. So these are two major functionalities of IDS. And this is the source file watchdog.c and pathrater.c, and these are functions. The first function, add watchdog timer, which adds the watchdog timer to each node in the network, and the second one checks if the packet is sent before time expiries. And pathrater.c, and these are some important functions, that is add to blacklist and verify route reply. So first one is adds malicious node to blacklist, and second one is check if the IP address the route reply contains the IP of any blacklisted node. So these are some important source codes that can be used in IDS. Here in this scenario, two intruders are there. So when we apply the watchdog timer, so when we set any watchdog timer here, so when we send packet from source to destination and it gets to the malicious node, so up to our watchdog timer, it sends the packet. It says that it is a malicious node and changes its routes. Okay. So we use watchdog timer and pathrater functions to avoid this sinkhole attack. So these are some comparison of network performance. This one is your normal working, and this is your throughput of after attack. So no packet is being sent. When IDS is used, some of the packet can be recovered from that malicious node. This is application delay in normal mode, in attack mode, and in IDS mode. And these are some research areas in MANET. And these are some customer base of defense space industries, education, international and India. Now we will go to the software and see how we can work in this software. So this is the environment of software. For designing any network, we have to go to simulation and new. Then in internetworks, legacy network, in internetworks, we can design wired and wireless network both. In legacy network, we have pure Aloha, slotted Aloha, traditional Ethernet, token bus, token ring, ATM. All these network are in legacy network. Then advanced wireless network for MANET and WiMAX, BGP network, cellular network for GSM and CDMA, wireless sensor network, IoT, Internet of Things, ZigBee, cognitive radio network, and LTE network. So today we design one mobile ad hoc network scenario. So we can see some nodes are given there, and only wireless node is enabled. All the nodes are disabled. As in mobile ad hoc network, you need only wireless devices. So all the devices are disabled because we need not there in the MANET. So we need only wireless node. So we place 6 devices here. So we are analyzing that on increasing the node mobility, as as we know that we can provide the mobility to these nodes. So when we increase the mobility 2 or 3 times, so what will be the effect on the throughput, we will see in this experiment. So first of all, we have to change the coordinates of these nodes just to align them in one location. So for first node, when you open the properties, we have global properties like device name, device type, its location, Wireshark can be enabled or disabled. Mobility model is there, and that it is random walk, random waypoint, group mobility or file based mobility. So we will set here random walk and its mobility to 10 meter per second. Okay. So first of all, I'll just set their locations, then I'll elaborate with the properties. We'll give the x coordinate to 250. Second one 200 and 150. Then for third one 300 and 150. Then fourth one 250 to 200. Then node 5 is 225 to 125, and mobility model to random walk. Then for node 6, mobility model is random walk and x coordinate as 275 and 175. So we have set these properties. We have to change the mobility model to random walk for all the nodes. So I'll show you the properties of this wireless nodes. So this global property, application layer is outside. You can get the details from outside this property. And transport layer is there, where TCP and UDP protocol is there, and we enable UDP protocol there only. And here you can see some information tabs are given to understand this parameter. So if you open this I tab, you can have the information about this congestion control algorithm. Then window size, if you click on, you can get the definition of window size. So likewise, you can understand the parameters given in NetSim by clicking on these information tabs. Then in network layer, you have the routing protocol from DSR, AODV, ZRP and OLSR. Then acknowledgement type you can define. Then interface wireless is there, where you can see different layers parameters like network layer. In network layer you have IP address, subnet mask, default gateway. Then in data link layer you have protocol, and these are standard. Enabled is retry limit, RTS threshold, rate adaptation you can enable or disable. Then in physical layer you have standard, you can change. Transmission power you can define. Then you have standard channels, you can vary. Some parameters are default and some are variable, so you can change the variable parameters according to your requirement. So likewise we have other properties. So when in the environment, when you right click, you will have the properties of link type, the multi-point to multi-point, link medium, wireless, and channel number, channel characteristic. So we set this channel characteristics as line of sight and path loss exponent as 2. Now we can model the traffic by dropping this application tab here. When you right click on properties, you can see one application is there, where we can add various application type like CBR, custom, email, HTTP, video. This kind of traffic we can enable. So first we will enable custom type of packet from source ID 1 to 4. Distribution would be constant, the value would be same. Inter arrival time and packet size, so you can vary this distribution, packet size and packet arrival. You can change these values. So we are adding this custom type of application in node 1 to 4. Okay, then we will add one more application by clicking on add. Again set one custom type of packet from node 2 to node 3. All the parameters will be same. Then we will add one more application of the custom type, and node source would be 5 to 6. Okay, now we will accept it. We can see this line that shows we have selected some applications, custom type of application from one source to destination. So there are some of the parameters that you can analyze in packet trace, event trace, and dynamic matrix. So these are available in standard version only. So these analysis can be enabled from here by clicking on packet trace, and these attributes are available in packet trace. Just have to click on OK. And for event trace, these are the attributes. Then dynamic matrix, you have the link matrix, application matrix, and these are attributes. Just click on OK, and you can run the simulation. And one more thing you can enable here, you can enable Wireshark. So when you enable it, you can see real-time packet capturing in the Wireshark while running the simulation. So now we run the experiment. Now as we have enabled the Wireshark, we can see that these are protocol metrics, and these packets are being captured here, UDP packets. Our simulation is still running. While running the simulation, it will capture the packets the real time. So now after the simulation, we will get the performance metrics of the network. Where some matrices are given like network matrix, link matrix, device matrix, application matrix. All these metrics are given there. So first of all, network matrix. So it will give you the overall analysis of your network, that is simulation timing, packets transmitted, packet errored, packet collided, then bytes transmitted, payload transmitted, and overhead transmitted. So here a lot of things can be analyzed, like network matrix. It is link matrix. Okay. So what link have been followed? You can see the collided packet, error packets, packet transmitted. Then in Q matrix, IP matrix, UDP matrix, DSR matrix, then power model matrix. Now what we are doing here, we are analyzing the overall throughput of our network. So in application matrix, for all the application we have added 3 application. So each and every application we are having throughput. So when you combine this overall throughput, we have to add this. It will come around 4.8 something, the overall throughput. So we are analyzing this overall throughput only. And now we have enabled this link throughput and application throughput. So we can see the link throughput graph. Then in application throughput, we have added 3 types of application. So we can see the graphs of application 1, 2, and 3. Then TCP congestion window graph. Then we have enabled the packet animation. So we can see the packet animation from here. When we run the simulation, we can see packet moving from source to destination. As soon as you get the acknowledgement, it will send the packet. In the green line, you can see the packets are moving, and it is written custom. So you can increase or decrease the animation speed to see the animation faster. So according to the speed, 10 meter per second, it is moving from its position. And this is our analysis that on increasing the speed of this node, how much it affects our throughput. So now we will go back and change the speed of the nodes and see the variation in our throughput. So first of all, we will save this experiment. Okay. One more thing is remaining, that we have added packet trace and event trace. So we can open the packet trace, and it will open in Excel format where we can see our each and every packet detail. Okay. From where it is moving, source and destination, either it is successfully sent or not. All the details is there, each and every packet detail. We can filter it and analyze one by one. Like the packet trace, we have event trace. So as the NetSim is a discrete event simulator, so it records the every events in the event trace, and you can see one by one each and every event performing in the network. Each and every event is there. You can use the filter tool and analyze the events. Now we will go back and edit our experiment and change the speed, the velocity from 10 to 30. Okay. Now we have changed the velocity from 10 to 30 seconds. Now we have seen this real-time packet capturing. So we can disable this Wireshark. Now we will simulate it and see what happens to our throughput. So now we will see the throughput in application. There are all the three applications are there. So now when we add it, that is 27. It comes around for 0.44, around 0.4 it comes. Okay, so we can see that our throughput has decreased by increasing the node mobility. So we can see in the animation also. When we increase the velocity, our packet will be lost more and the throughput will affect, it will decrease. So movement is very high here, so that's why a packet will get lost more and throughput will decrease. So you increase the velocity. Now we again go to the environment and increase the velocity from 30 to 50. Okay. Now we increase the speed from 30 to 50. Now when we run it, now when we go to the throughput, you can see it has decreased a lot. It has come around 0.18, 0.18, 0.19. So you can see in the packet animation also. So movement is very high here. So packet will get lost and throughput will decrease accordingly. So we have seen after increasing the velocity of the nodes, our throughput have decreased. So we can save this one also. There is one more thing in NetSim. There is a NetSim analytics. So we can compare various matrices here by browsing this matrix from here. Like if we have created MANET 1, 2 and 3, we can add this matrix. So we can compare these matrices according to their packet transmitted, packet errored, packet collided, bytes transmitted, payload transmitted, and overhead transmitted. So we have taken the three matrices of the same MANET scenario, and we have changed their parameters one by one, and we can analyze those matrices and see the variation in the result according to these parameters. So we can add multiple matrices and compare those. So this is the flow of working in the software. We have used this MANET scenario today, and yesterday we have used the inter-network scenario, wired and wireless. Yesterday I have shown the custom code also. So if yesterday some attendees were not there, so I'll just show them in brief how we can edit the custom code in this NetSim. So for editing the custom code, we have to go to the installation directory of NetSim, that is C program files and NetSim standard, where bin folder is there. In bin folder, all the protocols are given in DLL extension. You can see libarp, libatm, BGP, all the extensions are given here. So if we have to create our new DLL protocol, or we have to edit any protocol, we have to save it in this DLL extension only, because NetSim understands this DLL file, so you have to make it in DLL. So in SRC folder, when you click this netsim.sln extension, that Visual Studio environment will open automatically, and it will show you all the protocols used in the NetSim, their files. So we have opened one of the file called desa.c and added one hello world command in it. Okay, so when we build this DLL and copy it into the DLL that bin folder from this DLL, like libdsa.dll file is created, and if we copy it in bin folder by renaming our existing libdsa.dll, that is our original file, we have renamed it to libdsa default.dll, and this is our edited DLL libdsa.dll. We've already copied it. So if we run our experiment by using this libdsa.dll, so if we run this MANET scenario, you will first think you will observe the hello world printed here in the command line. So we have edited that command, that DLL, by writing the hello world program in it. So first of all, it will print hello world, and when you put enter, it will simulate your result. So this is just to show you how we can edit our protocol by writing any command in the Visual Studio, and when you build it, on right click build, it will generate the DLL file that is available in the DLL extension file. Here you have to copy it into the bin directory by saving your existing DLL, by renaming it. Then when you run it in that GUI, NetSim GUI, it will call your DLL function. So this is just to show you how we can edit the protocol. Now, apart from this simulation, we have some programming exercises given. You can see. Let's say when we open this shortest path, and when we run it, you can define the algorithm, number of routers, then you connect it, okay. So we have created this network, and we have to give the source router, let's say it's 3 and destination is 1. When you run this program, there is a backend programming in this sample program for the shortest path, so it will run according to that logic. So when you run it, it will calculate the shortest path that is required to send the packet from 3 to 1. So you can see the 3 to 1 is the shortest path, 66. So that is the sample programming running. When you open it in interface source code, it will automatically get open in Visual Studio. You can see link state.c. This is your program. You can modify it and save it accordingly into the exe extension. So as you can see, when you want to create your own file, so you have to go to the user, and it will ask you an executable file, exe file or zar file. So you have to create your file into these extension only. So when you browse this file and open it, then your that shortest path algorithm will work accordingly. And concept algorithm and pseudo codes are also available here for study purpose. Manuals are given: user manual, source code manual, and experimental manual. Some of the experiment have been designed on different technologies that might be common to some universities, or that are not available here. We can create it. So these are the experiments available. Step by step procedure is given. You can work on it. So now I've completed my presentation. If you have any query, you can ask me by writing it in text box. There is one question about the pricing of NetSim standard version for research purpose. So for pricing, sir, we will mail you the details regarding the price. There is one question about performance metrics. So what is confusing about, sir? Can you elaborate? I'll just show you again the performance metrics. If you open that matrix, yes, sir, performance decreases. That's what we are analyzing. That on increasing the speed of, according to the speed of, if we increase the speed of the nodes, the output decreases. We are analyzing this application matrix where throughput is given. So in first part where velocity is 10 meter per second, no, sir, you can see this is first matrix that is having 0.11, 0.16, 0.186. We are calculating the overall throughput, sir, for all the applications. So when you add it, it will give you the overall throughput of your network. So the overall throughput will decrease when you increase the speed. There is one question about does it support VANET vehicular ad-hoc network? Sir, we have interface with one of the open source simulator, that is Sumo for VANET. We have integrated it. Sir, this is not the order of increasing or decreasing. For calculating the overall throughput, you have to add this overall application throughput. So if you add it, it will give you the overall throughput of network. So this is one of the case when the speed is 10 meter per second. Now when we increase our velocity, the overall throughput would decrease. So in first scenario, it is around 0.48. In second scenario, it is around 0.4, and it is third scenario when it is 50 meter per second, it is around 0.18. So the graph is decreasing for the overall throughput. There is one question about compatible with Windows 7 or Linux. So this is compatible for Windows 7 and 8. It doesn't support Linux, sir. There is one question about licensing. Sir, this software comes as a USB dongle license. So when you install it, You have to create one server and client. On server, you have to connect the Dongle license. Then all the client will access the license from there. For delay matrix, sir, we have not analyzed in it, but you calculate it according to your experiment. If you have any query, you can write your query on my email ID. Or I'm giving my mobile number also.